Okay, we did this problem, one that I just drew. Got it. Oh, Maxim, did you send me the last lecture? Yeah, please make it and send it to me. So this is x plus y is equal to 1, if I remember correctly. And you were supposed to find the area of this triangle. So from elementary geometry to integrate first over x, then over y, 3 integrate first over y, then over x, 4 in polar coordinates. Hi. Oh, you are unrecognizable. What happened to you?
My hair.
I suppose so, yes. You look like Trump.
As it is more work.
I proved that Byron was the Pope, a dead Pope. I think I don't have to prove that you are Trump. You are visibly Trumpish. Whatever got into your head, but the effect is not white. This is, it will not turn white. What? Hydrogen peroxide? Hydrogen peroxide, is that what you use? H2O2?
No.
Then?
No.
What kind of bleach did you use? You don't know the chemical constitution of what you
No,
use? Yeah.
Okay. No, it is a bit more. I can't bleach it like 2 times in a row. Would destroy my hair.
It will destroy your hair even once. Hydrogen peroxide is normally not what one puts on one's hair, unless one wants to be what used to be called a peroxide blonde. Does anyone know about Perry Mason? Perry Mason, it's an ancient TV show from the US. And before that, it was books. Perry Mason was a lawyer. And they had all these cases, and these stories. I remember one that was called the case of the bewildered blonde, the case of the bewitching brunette, etc. These were the names. So you look to me like the bewildered blonde. But it's orange. It is orange, and therefore one will think immediately of Trump.
I know. The same thing. And I was no one had said that so far.
Well, Trump didn't have. This is the closest approximation to Trump that I've ever witnessed at close quarters. No one can see you. You should, I mean, they say they can't follow the conversation. You should appear in person so that they can see. Okay, in polar coordinates.
Next week, actually, I won't be able to come here on Thursday, but next week's gonna be white. Yeah.
It will not become white. It is impossible.
There's something called toner.
There's something called, oh, you want to paint it with some opaque substance which will make the individual filaments white? That, in fact, is possible.
Yeah. So like
well, do not be surprised if you start looking like me, if it kills the roots. Yeah. I beg your pardon? I had a full head of hair. It all disappeared after I came to the United States. I did not use peroxide. Okay. In polar coordinates, In polar coordinates, what's the last one? The last one was was it U or V? U is equal to X plus Y, and V is equal to Y in these coordinates. Yes, I mean, I didn't remember what was in the notes, but this is the example that I always used to do because it's a very good one, which you can do in all these coordinates, and the answers will come out to be exactly the same, and it's worked out in the notes. Okay, so you really have to understand all of this very well. The problem that you have on the exam, may I have a look? You have the exam? Well, never mind. Can you? So I just want to have a quick look. I was hoping to use these lectures next time, but this business about an approximation to Trump will not be understood by the students if they don't see you. So we have to have an yes, okay. You are also 30? This is the solved exam.
This is the solved exam.
Okay, and then what do I do? I hit this one, right?
No, you scroll down.
Okay, just a moment.
That is a lot of work.
It's not a lot of work. It's
Writing
just,
it out is going to be a lot more difficult. Well, it's going to
yes,
be a
but
lot
this is, we are now grown up, and so we have to,
bigger.
yes. We used to do these problems as a single problem in an exam.
Well,
Just one for yes. There was no such thing as take home, etc. I've sort of,
I don't even do that.
well, all of us did. Everyone, everywhere in the world did. 2B, yes, 2B was this one. And what's 3A? 3 is the cone intersecting a cone. Yes, intersection of the two cones. Okay. Okay, now that's fine. The first one is this problem. It's an area bounded by 3 straight lines. These 2 straight lines, 1 and 2, are symmetrically situated with respect to the diagonal line. Okay, and this problem has a lot of intricate calculations in it and needs to be done properly. Otherwise, it will be a complete nightmare. So while you do the work, you have to understand exactly how the different things are set up. And the addition formula for the tangent is used rather nicely because the slopes of the 2 lines, which are reciprocal of each other, because we are measuring with respect to pi over 4. So you go a certain distance from pi over 4 below it and a certain distance from pi over 4 above it. And that's why it is very important that you understand. Clear to everyone? Okay, so this first has to be done, and now I've forgotten altogether. I suppose do it first x, then y, then first y, no, first elementary geometry, then x followed by y, then y followed by x, then polar coordinates, and finally, there's a special coordinate system that is prescribed for you. That's in C, and you have to do it that way also. Clear to everyone? And if you don't do the C parts, that means you really didn't learn anything. All you did was to replace the numbers suitably. But even that, to go through the whole procedure, requires an idea of how intricate the work is. Is this clear to everyone? Okay. Incidentally, these things come up in, remind me that I have to talk a little bit about the places where they come up. Okay. The next problem, this is 1ABC. 2ABC is this problem. There's a circle like this, centered at KK. K, I have already given you K. And then you have to find this. So again, elementary geometry. Okay. Then integrate in Cartesian coordinates, I think. Then integrate in polar coordinates. Then integrate in polar coordinates based not at the origin, but at that point. And finally, I have not told you what coordinate system to use, but a special coordinate system tailored to this particular problem. That's C. Really? Oh, C is a, sorry, so this is 2AB. You are right. There was a hyperbola problem.
For C, I remember there was something like use a coordinate.
Oh, coordinate system. Yes. 2C, sorry. So 2C is a different problem. And it's a hyperbola. XY is equal to something. Could you bring C over just so that I could have a quick look? Okay. So Riviera couldn't come today. Okay. So we shall call you Arash peroxide Khavaron. Or if you prefer, Arash H2O2. H2O2 is no. It depends on the medium in which you dissolve it. So this question doesn't. If it can, yeah.
The index
Okay.
was the number of like if it has an H in it.
No. If the H comes out. Yes, I remember. Yeah. Thank you. Okay. So 2C is the same problem as 1A, except that this side has been replaced with a hyperbola. The straight line has been replaced with a hyperbola, and you are supposed to use good coordinate systems that are suited to this particular situation. Okay. 3AB is this. You should go to the ice cream shop and ask them to give you ice cream. Oh, that reminds me. I'm supposed to treat you to ice cream. Oh,
During the lecture.
yes.
Okay. I'll take it.
Yeah, we can all go.
I'm the only one that's getting ice cream though.
Why? Oh, because he didn't.
No, he also did one, but he can have more.
That's
So-
okay.
Okay, let's do it. Let's do it.
Yeah. So this is two cones sort of upside down. We can ask the ice cream people if they could give a cone like this as a practical, what should I say, as a practical tribute to 271. Okay. So you have to find the volume, I think. If you have to find the amount of ice cream, I will have to give you the density of ice cream. And you would have to find triple integral of dx dy dz over the double cone of the density of ice cream. That's a scalar field. So this is, you are integrating a scalar field. That will give you the total amount, which is the mass. Not the volume of ice cream, but the mass of the ice cream. Okay. 3C is the force sphere. But the force sphere, I sent an announcement with a Wikipedia article which has calculated all the volumes. Not just this force sphere, but of 5 spheres, 6 sphere, all the way up to n sphere, which reminds me of something. That is this 360 degrees nonsense, about which I also wrote on the announcement. At some point in the past, within the last 10 years, maybe 15 years, suddenly everyone started saying that, oh, we provide 360-degree service. And I had no idea what it meant. Apparently, it's the silly people being fancy. 360 degrees, they finally discovered, is the number of degrees in a circle. So apparently it means all around. But this is a circle in the plane, right? What is the circumference of a circle? Or rather, what does plane geometry tell us? What is pi? Where does it occur in nature? Opposite, other way around. Ratio of the circumference to the diameter, but you have forgotten one clause. If I draw the circle on the surface of a donut, yeah, in the plane. So a circle in the plane, the ratio of the circumference to diameter is equal to pi. If it is not equal to pi, you know that the surface on which you are is actually curved. So note that if you are on the sphere, if you draw this great circle, the equator, and if you take this circle passing through the North Pole, then this circle will have half this length, right? So circumference divided by diameter would be equal to 2. In that case, in the case of a circle drawn on the sphere, the one that I just said. So it is not equal to pi. So in that case, we know that it is, so depending on the curvature, this ratio is either above pi or below pi. So on a saddle surface, if you draw a circle on a horse's back, the horse may not be amused, but you can calculate pi, not pi, but the ratio, and find out what that is. Okay? If you draw a circle on the horse's back, how do you draw a circle? How is a circle defined? It is the set of all points that are at a fixed distance from a fixed point. So you choose some point on the horse's back, take a piece of string, and yes, draw the circle using some sort of a, some sort of a thing that would make a mark. Hydrogen peroxide, for instance. In a syringe, you can draw through this, the horse will be circularly blonde because of peroxide on its back. So, I beg your pardon? The horse will not be amused. But actually, do you feel it? I mean, hydrogen peroxide can actually.
I'm not sure if hydrogen peroxide, I'm trying to find out.
It didn't say? On whatever it is that it must have said something on the bottle. How did you know that it was not some horrible poison that would make holes in your skull? Very bad logic. Okay, so before I forget, something is an acid if in the medium in which it is dissolved, you have free H+ ions. This may not be the case in different mediums. So hydrogen peroxide is a good example, which can behave as a base or an acid depending on the medium in which it is dissolved. I beg your pardon?
That's what I was told.
Yeah, but that is the problem, that it is not an intrinsic property of the substance. The question depends on in what medium you dissolve it. Okay, so actually there's even something even more silly that is normally taught to children, which is this a chemical change or a physical change? It's nonsense. There's no definition of it's absolute nonsense. Chemistry is a part of physics. Chemistry essentially deals with the dynamics of external electrons of atoms. And that was discovered in the 50s. Anyway, I will send everyone these papers, which I want you at least to read the abstracts of, just to have an idea of it. Since having come across a practical use of hydrogen peroxide, my resolve has been strengthened. That means I should do so soon. Yeah, already it is very bad logic, even worse grammar. So what is the subject of the saying? A chemical change is when? What kind of sentence is this? A chemical, yeah.
It's a process that
A process is said to constitute a chemical change by definition if and only if what?
the structure of the molecular structure of a matter changes.
The molecular structure of matter does not change. Sorry. The molecular structure, yes, the molecules can change. Yes, yeah. But that's just I mean, all that means is that the atoms are redistributed. But this is physics. I mean, if atoms are physical objects, the certain atoms form the structure called a molecule, and the atoms get redistributed, as it were. So what is? So what? What is a molecule? Well, a molecule is just a kind of solution of the Schrödinger equation. It gives you the probability density. So it's physical objects getting redistributed. So this is the kind of thing that really bothers me, because it makes absolutely no sense. Anyone who thinks about this carefully would realize that. What I want you to understand is these are arbitrary divisions which make no sense upon further scrutiny. As long as these silliness continues on an exam, particularly if the results of the exam are important, just say whatever nonsense they have taught you to say. So this is one bad thing about chemistry. The other bad thing about chemistry is to balance chemical equations. Apparently, one has to do this by trial and error. These are trivial linear equations which you can solve by row reduction. Yes, and the point is that you will get fractions and you multiply by the least common multiple and you will get solutions which are absolute. So there's no trial and error involved. Okay. So the last problem, 3C, this is not 3C, this is the circle on the torus. Maybe I should remove 3C and draw the circle on the back of the horse. This is the back of the horse. And this is the circle. That's a very bad picture, but nevertheless. Maybe I should draw the horse differently. That would be an interesting problem, to find the area of the saddle. So this is a better description of the horse. So this is the, yeah. 3C is the force sphere, which I, of course, cannot draw. I sent you a video about the force sphere, but the force sphere, as I told you, is all the formulas given in Wikipedia. And then so about pi. So, but we are in 3 dimensions. If I want to, why is this usage, 360-degree service, nonsense? If we want to compare the extent to which the mouth of 2 different crocodiles are open, this has opened its mouth more than this. You decide whether it is of a crocodile or a Pac-Man. So the question is, how do you measure it? The answer to that is that you draw a unit circle and you measure this length. Or you draw different circles, but you measure the ratio of the length measured along this arc to the radius. Okay, so this is the measure in radians. If you, depending on what you choose to be 1, this measure around all around the circle turns out to be 360 degrees or 2 pi. Okay, so, but what would you do in 3 dimensions? In 3 dimensions, the corresponding problem is that if you have an irregular cone, this is a 3-dimensional crocodile whose mouth, well, it's sort of, the crocodile is 3-dimensional, but let's say we are talking about cones. Okay, so in this case, you would have to draw a sphere, unit sphere, and look at this area on the unit sphere. And if you don't want to draw a sphere of unit radius, you take any sphere, but you compute the area, surface area, and divide by r squared. So this is called a solid angle. And since the surface of the sphere is 4 pi r squared, if you divide by r squared, the measure is 4 pi. So if you have to convert 4 pi, this is called steradians, which is the unit in 3 dimensions. Actually, it is dimensionless, so it is really unitless. Steradians or radians refer to the fact that we have used a unit circle or a unit sphere. Now, so that if you convert to degrees, it would be 720 degrees. If you really mean all around in 3 dimensions, you should cover yourself in a sphere. But that is beyond the capacity of these marketing managers. Hence, everyone provides 360 degrees and everyone is happy to sound so fancy. Okay, so now, what is the volume of the 4 sphere? Who can look it up? From Wikipedia.
4/3.
No, that's the 2 sphere.
Oh, 4.
Yeah. 4/3 pi r cubed is of the 3 sphere. Look it up on Wikipedia. Put n sphere and see what it gives you. Not integral of the 1 sphere. There's a recursion, but it's more complicated than that. Vn is equal to,
Because 1 sphere is a row of the circumference.
no, what does it mean to integral of the circumference? It doesn't make any sense. It's the 1 sphere is generated, the 2 sphere is generated by revolving the circumference of the 1 sphere. Yes, that's true. So give me the volume of the 4 sphere and the volume of the 5 sphere. N sphere on Wikipedia, and I sent you that link. There's a beautiful picture. Yeah, what's the volume of the 4 sphere? I don't remember. Is it the 4 sphere that has a pi squared in it, or is the volume of the 5 sphere that has a pi squared in it? Towards the middle of the page, you will see a horizontal chart.
pi squared.
1/2 pi squared. And volume of the 5 sphere? 8/15 pi squared. So you see now we have pi squared. Okay. So is the volume of the 4 sphere that you have to compute. And it is a very simple exercise in using spherical polar coordinates in 4 dimensions. And it is done in many different places. So you should look at it just to see how the spherical coordinates are generalized to higher dimensional space. Okay, and actually carry out the integral and you should get the answer. So that's an easy problem. I'm telling you this because it's an easy 5 points. but you have to go through the work. Okay? Okay. That's half an hour. So what happened to Byron today? Byron is not on this either. Yeah, first turn the lights on. Is Byron there? I can't see who is here because it cuts it off. How many of you have seen the 3D printed thing?
I have, but I think I left it over here.
You haven't seen it.
It has 2 pixels over the internet.
I see.
Actually, yeah, he posted a picture on this. I've seen.
Yeah. Okay. So now, yeah. Yeah.
For the Jacobian coordinates, we need to calculate.
No, Jacobian is not a no. To compute the Jacobian for a coordinate system. So you can compute the Jacobian for polar coordinates or for any other coordinates. Yeah. So what about it? Yeah. So for the other coordinates, you will have to compute it. Yes.
Oh, so we have to compute it for all of them.
Yes. Otherwise, how are you going to integrate? If you're supposed to integrate in coordinates other than the Cartesian coordinates, then the Jacobian gives you the deformation factor. So the elementary area changes and it gives you the local deformation factor. What does so in polar coordinates, for instance, you have these spokes and circles. These are the level curves because they correspond to R is equal to constant, which is if and only if x squared plus y squared is equal to constant, and theta is equal to constant, which means arctangent of y over x is equal to constant. Let's call the constant k. So x squared plus y squared is equal to square root of k squared, that is a circle. And this is y is equal to tangent of k x, which is a line through the origin. So these are the level curves. No one answered the question, what are the level curves? I told you in class that they are lines through the origin and also ellipses on the last exam. I actually said that specifically in class. Okay. So these are the level curves. So now the elementary area, which is the rectangle in this system, looks like this. It can also look like this. In the Cartesian coordinate system, the grid lines are vertical and horizontal, so they are little rectangles. So to go from here to here, there's a deformation, and that deformation factor is del xy del r theta in absolute value. Okay, and so in higher dimensions, it will be del x1 xn, u1, u2 up to un.
So the Jacobian is supposed to be calculated for anything except for the piece.
Yes, in the Cartesian coordinates, it is just equal to 1. Okay. So the Jacobian is basically the transformation factor, the deformation factor. Okay, I mean, it happens in when we computed the determinants in 270. It came up, we didn't call it that, but it would come up in determining the determinant of a linear transformation, yes. It was in the change of basis. What happens is that if you have a cube, let's say, And if you apply a linear transformation from 3 dimensions to yeah, this is a very bad cube. This is an even worse cube. Let's see. Okay. If you have a cube and if you have a transformation, a linear transformation from 3 dimensions to 3 dimensions, the cube gets transformed into a parallelepiped. So if this volume is 1, you can choose this has to be unit. The volume of this is the volume of this one is the determinant of the linear transformation. So the determinant of the linear transformation actually measures the deformation. So in the case of the change of coordinates locally from the x1 up to xn basis, you are going to the u1 up to un basis. So if you compute the Jacobian, you are getting the deformation of the infinitesimal volume element. That's what it gives you. Okay. Okay. So now in 3 dimensions, in the notes, is it done in 3 dimensions or 4 dimensions? I think I did it in both. No, I must have done it in 4 also. So I said that there's a pyramid with a triangular base, and that is bounded by x and x plus y plus z less than equal to 1. So this is bigger than 0. Yeah, may I have a look?
The last example is like the highest dimension.
Yeah. And then it's not done in 4 dimensions. W, X, Y, Z.
It kind of stopped there. There's one in the questions, but it's not.
Ah, yes. Okay. So that's, I didn't work it out. And I also asked you to compute it in n dimensions. Okay. The answer to your question where it came from is the Jacobian, which is calculated in the coordinates notes. Okay. Okay. So this one, again, we have to integrate dx, dy, dz. And then how do we integrate? First, we integrate over z. If we do that, I have a little volume there and I go up like this. So here the equation is x plus y plus z is equal to 1. So if I subtract x and y from both sides, I get z is equal to 1 minus x minus y. So this will be equal to dz so this is over the pyramid. We call it pyramid P. dz is equal to 0 to 1 minus x minus y. Okay. Now, how do I find the limits of the other two? If all of these have been calculated, we have something on the xy plane where at different points these volumes are concentrated. So now this line, which is the intersection of x plus y plus z is equal to 1 and the plane z is equal to 0, has equation x plus y is equal to 1, because x plus y plus z is equal to 1 and z is equal to 0. This plane is z is equal to 0. The xy plane is z is equal to 0. So this line is x plus y is equal to 1. So y would go from 0 to 1 minus x. So I am integrating over y, which means I go in this direction. Then the projection leaves me just with the x-axis. So now there are these densities concentrated, and this is the point 0, this is the point 1. So then x goes from 0 to 1. Okay? So this is how it is to be carried out, and you just work it out. So even though I just stated as a problem, in n dimensions, volume of the pyramid in 4 dimensions can be computed without drawing the picture dz. So the equation is w plus x plus y plus z less than equal to 1. So equal to 1, basically, right? So this will go from z is equal to 0, which is the xyz hyperplane, to z is equal to 1 minus w minus x minus y. Then y will go from y is equal to 0 to y is equal to 1 minus w minus x. Then x will go to from x is equal to 0 to x is equal to 1 minus w. And finally, w will go from 0 to 1. And now you can see the pattern, what would happen in n dimensions. Okay, those are the 2 problems that I have assigned. Okay.
We would have to do the same thing for every other iteration.
Not iteration, but permutation. Yeah, and the answers will be the same. Yes, otherwise, I can't say that if I measure your volume by one method, I get V milliliters, but some other method gives you something else. Right? So if I have to sell some gold, I will use the method that will give me a larger volume. But that, of course, doesn't work. Yes, but it doesn't work. So okay, do you get the general idea? Now, your knowledge of coordinate systems is extremely shaky. And that is not going to help. On this exam, you will get by because all the problems are worked out. But but in order to understand this, you really have to understand the coordinate systems and work it out. Let me ask you this. Suppose I have this coordinate system. R is equal to x squared minus y squared. No, sorry. Let's see. That's not what I meant. I meant, yeah, x is equal to r cosine hyperbolic of theta. And y is equal to r sine hyperbolic of theta. Okay. So if I say solve x is equal to r cosine hyperbolic theta, y is equal to r sine hyperbolic of theta for x and y, for r and theta in terms of x and y. And this is an analog of x is equal to r cosine theta, y is equal to r sine theta. where you were supposed to solve for r and theta in terms of x and y. What was the fact that I used about cosine theta and sine theta that allowed me to get rid of it? No, no. What, in order to eliminate something, you have to have a. No, I am asking you about what is the fact that we have to use to get rid of theta. That means to get rid of theta, I have to use something that has theta on one side and no thetas on the other side.
The tangent?
That doesn't work because that has theta on both sides. No, you don't understand this at all. So this is a very dangerous situation. Very dangerous.
Not the tangent?
I beg your pardon?
Yeah, the trig function tan.
No, but you're not answering the question. I want an equation in which there is theta on one side and no theta on the other side. So elimination is carried out using equations in which an unknown No, you are not understanding the principle over here. The principle is what is important. So the principle, you have not understood the principle. That is clear. Okay, so now let me give you the following example. Suppose I say, okay, no, not I say, for every x and y in the real numbers. This is a basic arithmetic lesson, which you do not understand. X plus y, the quantity squared, is equal to x squared plus 2xy plus y squared. Everyone understands this? Why is this true? Well, you multiply. It is the binomial theorem. You multiply and see that that is the answer. But what does it mean geometrically? Anyone has any idea? No. Intersection of what? No. Where are there no lines over here at all? What is the geometric interpretation of x squared? How can x squared be a parabola? It is just a single term. So I am asking you for some geometric object which has a property whose measure is x squared. If you draw a square on side x, what is x squared? X squared is the area of the square. So if you keep this in mind, if you take x plus y, the quantity squared, it is the area, it can be interpreted geometrically as the area of a square whose side is. If x squared is the area of a square whose side is x, x plus y, the quantity squared, is the area of a square whose side is what? Yes. So this is what we are supposed to do. I have to draw a square whose side is x plus y. And now this whole thing is the square of x plus y. So you see that it is equal to x squared, which is this one, y squared, which is that one, and xy and xy. That's what this is saying. So if you don't know this immediately, that means you really haven't learned these things at all. This should be immediately obvious. Similarly, what does it mean to say x squared minus y squared is equal to x plus y times x minus y? if you remove a square of area y of side y from a square of side x, in that case, what remains is the area is equal to the area of a rectangle of size x plus y and x minus 1. No, that doesn't say anything. The area of a rectangle whose sides are x plus y and x minus y. Why are you using this vague sentence which lacks precision? Okay, so let's see if this works. This is of side x. This I normally would do with this is removed. So you get this L-shaped thing. Right? What is this side? This side is x, the whole thing minus y. So this is x minus y. So, and what is this side? That is also x minus y. So I can take the piece, this is x. This piece I can cut it and I can put it over there and it will fit perfectly. And this is y and this is x. So this is x minus y. This side is x plus y. So this is saying that if you remove a little square of side y from a square of side x, then the resulting figure has area equal to a rectangle, which is x plus y times x minus y. Is this clear? Okay. So now again we go back for every xy in R, x squared plus, sorry. Yeah, no, x plus y, the quantity squared is equal to x squared plus 2xy plus y squared. And minus x plus y, x minus y, the quantity squared is equal to minus x squared plus 2xy minus y squared. These are equal, these are equal. So equals, why is it not going away? Swap it which way? Okay. Okay, so equals added to equals give you equals, equals subtracted from equals give you equals. So I get x plus y, the quantity squared, minus x minus y, the quantity squared, is equal to 4xy. And this is true of every x and y in R. Is this clear? Okay. So suppose I substitute a in the place of x and 1 over a in the place of y. I would get a plus 1 over a, the quantity squared, minus a minus 1 over a, the quantity squared, is equal to 4 times a times 1 over a. And let's assume that a is not equal to 0. So what did that give me? A plus 1 over a, the quantity squared, minus a minus 1 over a, the quantity squared, is equal to 4. Right? This is an identity which has a on one side and no a's on the other side. What does it mean? This is true of for every a in the real numbers without 0. A plus 1 over a, the quantity squared, minus a minus 1 over a, the quantity squared, is equal to 4. Do you believe this? Okay. So this is true for every, so no matter what number I pick, this should work out, right? So let's try 2. So 2 plus 1 over 2 squared is equal to 5 over 2 squared is equal to 25 over 4. 2 minus 1 over 2 squared is equal to 3 over 2 squared is equal to 9 over 4. 25 over 4 minus 9 over 4 is equal to 25 minus 9 over 4 is equal to 16 over 4, which is equal to 4. Shall we try something else? Of course, it is true for everything. But what is remarkable about this? That on the left side, there's A, on the right side, there is no A,
That's the answer.
equal to 4. So now suppose I put in the place of A, a tower of 9s, which a tower of 9s, 9 to the 9 to the 9 to the 9. If you go about 20 high, in that case, you exceed the number of atoms in the known universe. So what does it mean? That no computer that you could build would ever be able to calculate. But we know that the answer is 4. This is why the brain works differently from a computer. No artificial intelligence, ChatGPT, etc., will be able to figure it out on its own, because we do not know how the brain is structured. So this is an elementary demonstration that the brains function differently. Do you understand the significance of this? Okay, so now let's deduce trigonometry from this. We know that if I divide both sides by 4, this is allowed, right? So what do I get? 1 over 2, 1 over 4, a plus 1 over a, the quantity squared, minus 1 over 4, a minus 1 over a, the quantity squared is equal to 1. Right? So this is equal to half a plus 1 over a, the whole thing squared, plus 1 over 2i, no, plus I squared is equal to minus 1. Is equal to 1. I did this for a reason. Suppose now in the place of a, I substitute e to the I theta. And in what would I get? I would get half e to the I theta plus e to the minus I theta squared plus 1 over 2i e to the I theta minus e to the minus I theta, quantity squared is equal to 1. But what is e to the I theta plus e to the minus I theta over 2? That's a famous formula named after de Moivre. This is nothing other than cosine theta. So this is saying cosine squared theta plus sine squared theta is equal to 1. So where did I start? I started with the equation for x plus y whole squared and x minus y whole squared. Okay? So this is an equation which has theta on one side and no theta on the other side. Do you understand this now? What's the corresponding equation for hyperbolic functions? Well, it's cosine hyperbolic squared theta minus sine hyperbolic squared theta is equal to 1. You should never have taken the placement test. You should have taken the class where they teach these things. Well, I was not teaching it. If I taught it, you would know. Okay, but this equation has theta on one side and theta doesn't have theta on the other side. So in order to eliminate trigonometric functions involving theta, this equation is a fundamental and can be used. Is this clear to everyone? Okay, so now suppose I give you, see that there's a very important fundamental thing that you do not understand. Suppose now I say x is equal to r cosine theta, y is equal to r sine theta. Someone has to move. Yeah. I want to, so x and y are known, r and theta are unknown. Okay. So how do I find r? In order to find r, I have to remove theta from the two equations. What is the equation that gets rid of theta? We just saw a moment ago. It's cosine squared theta plus sine squared theta is equal to 1. From this equation, we are going to compute cosine squared theta. How? Well, I square both sides. This one, everyone understands? So x squared is equal to r squared cosine squared theta. Here sorry, this is y. Okay. Y squared is equal to r squared sine squared theta. Now, I just write this below this one. And now I know these two are equal, these two are equal. Equals added to equals give you equals. So x squared plus y squared is equal to r squared. Cosine squared theta plus sine squared theta. X squared plus y squared is equal to r squared times 1. X squared plus y squared is equal to r squared. This is the equation of a circle of radius 1. So here I know geometrically that if r is equal to constant, you just are getting a circle. These are the level curves of r is equal to constant. Clear? Okay, so if I take the square root of both sides, I get square root of r squared is equal to square root of x squared plus y squared, which means r is equal to square root of x squared plus y squared. So this has given me the solution for r in terms of x and y. I still have to find theta in terms of x and y. What do I know? I know that r sine theta is equal to y. And r cosine theta is equal to x. Previously, I eliminated theta in order to find r. Now I have to eliminate r to find theta. So r is never 0 because of the way in which things were defined. So I can divide these two which are equal by these. So I would get y over x is equal to r sine theta over r cosine theta. The r's cancel. So tangent of theta is equal to y over x. If I apply arctangent on both sides, I get arctangent of y over x is equal to arctangent of tangent of theta, which means arctangent of y over x is equal to theta. So now I have an equation for theta in a solution for theta in terms of y and x. Is this clear? Okay, so we have two equations now. X is equal to r cosine theta, y is equal to r sine theta, and that led to r is equal to square root of x squared plus y squared, and theta is equal to arctangent of y over x. So now suppose I instead write r x is equal to r cosine hyperbolic of theta, y is equal to r sine hyperbolic of theta. The equation that corresponds to cosine hyperbolic square theta and cosine square theta plus sine square theta is equal to 1 is cosine hyperbolic square theta minus sine hyperbolic square theta is equal to 1 minus sine hyperbolic. So what do I do to find r? What procedure should we use? Yeah, to solve this system for r first. That's what I want to do. What did I do in the other case? No. No, we square both, yes. Yeah. So what do I get? X squared is equal to r squared cosine hyperbolic square of theta. Y squared is equal to r squared sine hyperbolic square of theta. What do I do now?
Now you can add.
Not add, but this equation is minus. Yeah, so x squared minus y squared is equal to r squared cosine hyperbolic square theta minus sine hyperbolic square of theta. That means x squared minus y squared is equal to r squared times 1, which means x squared minus y squared is equal to r squared. Which means if I take square root of both sides, I would get r is equal to square root of x squared minus y squared. And if x squared minus y squared is equal to constant, then those are rectangular hyperbolas. Like this. Okay? If it is negative, you get these. So these are grid lines or level curves. Okay, now how do I find theta? So x is equal to, y is equal to r sine hyperbolic of theta, x is equal to r cosine hyperbolic of theta. What did we do last time? Yeah, so we divide one by not be, you can't say we did y over x. We divide equals by equals. So y over x is equal to r sine hyperbolic of theta divided by r cosine hyperbolic of theta. These cancel. Y over x is equal to tangent hyperbolic of theta. What did I do at this stage? We applied arctangent. So the inverse of the tangent hyperbolic is called not arctangent, but argument of the tangent hyperbolic. So that gives me which means that we get argument of tangent hyperbolic y over x is equal to theta. So now I found theta and I found r, and therefore theta is equal to constant. Theta is equal to constant means argument of tangent hyperbolic y over x is equal to k. That means if we apply tangent hyperbolic to both sides, it gives you y over x is equal to tangent hyperbolic of k, because tangent hyperbolic of argument, this is tangent hyperbolic of argument tangent hyperbolic y over x, too many, is equal to tangent hyperbolic of k. So that means y over x is equal to tangent hyperbolic of k, which means y over x is some other constant. Tangent hyperbolic of k is a constant, so tangent hyperbolic of k is a constant. So that simply means that I have these lines. Okay? So these are the grid lines. So now you have hyperbolas and lines like this. That's a different coordinate system. Okay? Is the idea clear? So each coordinate, so there's a very important idea over here. If I want to prove something in the abstract about tangent planes or linear transformations or volumes and areas, I have to do this independently of coordinate systems. But if in a practical example I have to compute it, I have to employ a coordinate system which is best suited for the problem at hand. Do you understand what I'm saying? So I have to take the geometry into account. So I will send you papers later to all the science, the STEM majors, which shows how these strange objects like oloids and tri-cylinders come up in practical applications. Okay, so one is trying to understand how the DNA fits under the staircase, which is a constraint, or how you try to build better materials which would have special properties. All these things are of enormous practical importance. Or how do you find the shapes of molecules? Molecules are not living. Viruses are living. But living simply means at the moment that they can replicate. In other words, they can copy themselves. Okay, and this is a rather remarkable thing. In fact, viruses assemble like icosahedrons, which are these 20-sided solid objects, which is a platonic solid, which presumably minimizes energy, because which is a shape that is found all the time. So this sort of thing goes a very long way. Okay, let me try to give you another problem to see if you have understood what I just said. So x is equal to, let's say r. No, so not r. X is equal to u plus v, and y is equal to u times v. I just made up this coordinate system. How would you find u and v in terms of x and y? What would you do? You have to eliminate 1. This I'm these are two equations in terms of u, v and x, y. X and y are known, you have to find u and v in terms of, do you understand the problem? Yeah. Of the operations, addition, subtraction, multiplication, division.
So I would add, I would make like.
No. Again, your language shows the confusion. There are exactly 4 moves, 5 moves. Equals added to equals give you equals, equals subtracted from equals give you equals, equals multiplied by equals give you equals, equals divided by equals give you equals. This is the game board. You want u and v by themselves, and on the other side you can have only x and y. So how do you proceed? What is the first move that you make? In other words, I am, yeah. It doesn't make any sense to add y to x 2 times.
And then, also the
No, this is one equation. This is the second equation. So tell me, in terms of the moves that I specified, what are you supposed to do to the first equation? And what are you supposed to do to the second equation? Okay, if you want, okay, you can square the first equation if you wish. That is an allowed move. So let's square the first equation. That gives me x squared is equal to u plus v, the quantity squared. Okay, what now?
And the second one times 2.
So multiply this equation by 2. So you should say multiply both sides of the second equation by 2. That's the move. Okay, so 2y is equal to 2uv. Okay, what do we do now?
Add the equations together.
Add the equations together. So x squared is equal to u squared plus 2uv plus v squared. And 2y is equal to 2uv.
Sorry, subtract. Yeah.
Subtract equation number, the modified equation 2 from equation 1. Okay. So minus 2y minus 2uv. So this gives me x squared minus 2y is equal to u squared plus v squared. Before we proceed any further, what was our goal? Our goal was to eliminate one of the unknowns so that I get an equation entirely in terms of u. Have we achieved that? So you are playing very badly. In other words, worse than tic-tac-toe. See, I want to go through this to diagnose the problem. First, in order to cure a disease, we first have to have the correct diagnosis. Would you agree that I have diagnosed the problem correctly? That your understanding of equations is non-existent? Otherwise, you should be able to play this game. You are not capable of playing this game. And this is a trivial game. Okay, so back to square one, game board. X plus y is equal to, sorry, not x plus y. Oh, I've forgotten what the game was. X is equal to u plus v. Y is equal to uv. Your goal is to get rid of either the u or the v. In both equations, u and v occur symmetrically. Now, listen to me first before you say anything. In both equations, x, u and v occur symmetrically. That means if you interchange u and v, the equations don't change. So which one you choose to remove will not make any difference whatsoever to the process. That is the first thing that you know. This is like reducing your steps in tic-tac-toe. Okay.
Divide the second by
Okay, divide the second equation by v is a very good idea. So y over v is equal to uv over v. You have assumed that v is not equal to 0, which will make a quiet note of that. So this gives me x is equal to u plus v, y over v is equal to u. What would you do now?
subtract with by
No, subtract equation 2 from equation 1. Okay, y over v minus u. So that gives me x minus y over v is equal to v.
and
At least we now have an equation which has only v. We have succeeded in eliminating v. We haven't succeeded in solving it, but
I want to multiply by v.
no. Again, the language is wrong.
I want-
Multiply both sides of the equation by v. No, it is not self-evident, since you make the mistakes, not I. So learn to speak the language properly.
It's not right.
So xv minus yv times v is equal to v squared. These v's cancel. So xv minus y is equal to v squared. This is better than what it was before. What do I have to do now?
Wait, we're going to find v or we're going to find v, okay?
This is very slow. What is the highest power of v? Okay, an equation in the highest power, in which the highest power of the unknown is 2, is called what kind of an equation? Quadratic equation. So in order to use the quadratic formula, which can be used in this case, what do I first have to do? Yes. No, subtract xv and add y to both sides of the equation. As long as you continue to say sentences which are jumbled up, your head is in a state of confusion. The only reason which why I think is not entirely true in your cases, because your mother tongue is Farsi and your mother tongue is Ukrainian. So it may be the case that the mechanisms in use to lead to an English output are for some reason interfering. I don't know exactly whether that is the case or not, but I will take that as a working hypothesis. So this cancels, this cancels. So 0 is equal to v squared minus xv plus 1. This is a quadratic equation in v. So I can write that v is equal to minus x plus square root of minus x the quantity squared minus 4y divided by 2, or v is equal to minus x minus the square root of minus x the quantity squared minus 4y over 2. Okay? So we have solved for v. Now I can do the same thing for u. But it was exceedingly slow and painful, but maybe as a result of this exercise, your consciousness has been altered ever so slightly so that solving equations finally is something that you can answer. But this was an extremely inept way of doing the thing because of the following reason. Of the two operations, subtraction and addition, subtraction and multiplication, which is easier? Subtraction and division. Define easier. Okay, very good. How do you define multiplication? Repeated addition. Okay. How do you define subtraction, division? Well, if multiplication is repeated addition, division is? No. Repeated subtraction. If I want to, so 2 plus 2 plus 2 is equal to 3 times 2. Okay. If I want to divide 10 by 3, what do I do? 10 minus 3 is equal to 7. Okay. So as a result, since using an operation once is simpler than using an operation 15 times, subtraction is simpler than division. So, however, this has not been completely absorbed as an idea. Why? Because I divide. I would rather subtract. I subtract v from both sides to get x minus v is equal to u. But this is why. Equals substituted into equals give me equals. Therefore, y is equal to, in the place of u, I can put x minus v. So what do I get? Subtract y from both sides. 0 is equal to minus y plus xv minus v squared. Do you see the quadratic equation? So the previous one, I have to make a dynamic analogy. I ask you, where is your nose? And you go this way. Yes. At the very top. Yeah. Further up? Yeah. Yes. That you see this, if the whole point of mathematics is that what you learn in the past becomes ingrained like breathing. You don't have to think about it anymore. What is lacking? So this is again the diagnosis I'm making. What is lacking is sufficient understanding of basic algebra. Therefore, if you want to pile other stuff which is more difficult on top of that, it doesn't work because the foundations are shaky. Do you understand this idea? I have a very clear goal over here. I want you to become aware of what is lacking. So if the diagnosis is correct, you can address the problem. If there's no diagnosis, you can't address the problem. You can't go say that I have something somewhere. oh, doctor, cure me. It doesn't work. Of course, you can do a great. No, you think about it while you are swimming. There's nothing to prevent you from thinking about. You practice by thinking about it. So while you swim, try this exercise. While you swim from one side of the pool to the other, give yourself a problem and try to work it out in your head. Soon it will be very difficult at first because you will be thinking of other things, but gradually you will get used to it. Yes. Yes. No, he actually swims. It is not a metaphor. You should also do this. Before you go to bed, give yourself a few problems. Make them up. Just make them up and see if you can solve them. Sometimes they will be very difficult. I know. No, but this is the only way in which I can make you aware of these things. You see, this is why I really dislike online classes, and I think they're not good. Because online classes, because I am assuming that you, first of all, you are at the right level and that you will actually spend the necessary amount of time. But this is a false assumption, clearly. So I never taught any online classes ever at all before COVID. And it was only because of maths that I suddenly became conscious of how horrible a thing this is and how the students are being done a disservice, because of which I appeared in the library, which I will remember to until I die, because I will never forget the expression on Riviera's face. It's sort of etched in my mind. So anyway, so are you getting roughly what is going on and what needs to be addressed? This is not going to be, it is not going to help you if you remove this sort of thing altogether and replace it, as is being done in the United States, by pushing the green button, then the yellow button, then the blue button. You learn nothing whatsoever. So if ChatGPT and GPT-4 come into existence, it will, What?
I don't think anyone's.
Oh, that's complete nonsense. You have a counterexample, living counterexample. Yes. Not only that, I taught algebra like this over here. I taught exclusively arithmetic and algebra for many years. Oh, yes, they are. But this is exactly the point. Yeah. This is the stupidest way in which one can teach. Not only that, this is an absolutely certain method of making cabbages out of human beings. If the human beings are willing to be cabbages, then there's nothing further to be said. Both sides are happy. Okay. So this ChatGPT type of thing does infinitely more harm to your brain than hydrogen peroxide does to your hair. Anyway, so this, I mean, without you, this lecture would be completely useless. I think one of these days I have to go into one of these fancy rooms, and except that it is very boring to. No, there are fancy rooms where one can just see the hand and they can record it a video. Yeah, there are some high flex rooms at CCP. A high flex room is one in which there's a special not a blackboard, interactive surface where you can lecture.
Oh, okay.
Yeah, so you have to lecture and then it can be recorded.
Okay, yeah.
And then I can record those. These are more interesting, of course, because there is Arash and there is Max. And there's Nathan, who is occasionally awake.
This is the time of evening where.
You fall asleep.
Yeah.
Okay. Well, anyway, and we are missing Byron. So Byron also adds a certain element to the class.
I won't be able to come first. I won't be able
You will not be able to come on Thursday. So which means Max must come on Thursday. Okay.
I'll put my-
Yes, in the bag and not take it out at all.
Oh, actually. Thanks for 5 minutes today.
Peroxide.
Yesterday. Like yesterday, I left my iPad in the Bonell building and I had to go to the security room to like grab it.
Actually, if someone actually found it and
Oh, it was on a table with my friends. So like they just gave it to the security guard.
I see.
Yeah.
Okay. Well, I'm very glad that you found your iPad.
Well, especially the one in there. It's
Yeah, no, but I really wanted this is something serious. I think the reason why you don't understand this properly is because you were not taught it properly. And I beg your pardon? Yeah, well, this was magnet schools are American ideas. And no wonder. I told you that it is absolutely the worst system in the whole world, and this is exactly the proof.
like
No, I want you to make some problems up. Make one up for me right now.
It's like
X is equal to.
after the fact that
You were not a very industrious student.
I'm recovering from that.
No, you are all born with brains, and the brains need to be used. And you must always challenge the brain. I mean, that's the only way to keep it. Yes. Okay. X is equal to square root of u plus v. And y is equal to? Okay. So let's see. Shall I do it? Okay. And I'm going to try in public. Square both sides. I get x squared is equal to u plus v. Y is equal to u plus v. Okay. So low battery. Low battery. Shall I? What shall I say? Low. It says low battery.
Oh, just say.
Close. Okay. Okay. X squared is equal to u plus v. Y plus y is equal to u plus v.
We don't want to get.
So that. Okay. So no, but you see, this equation cannot be solved in terms of you cannot. In order to solve for two unknowns, you need to have two pieces of information. You have given me only one piece of information. That means you have just provided the sum of u plus v. You have just given it two different names. So this equation does not have a solution. Or it has infinitely many solutions.
By adding.
If x squared and y, well, this just.
By adding x2 equals u plus 2y, 2b.
No, so you see, by making up problems, you understand something. So if you gave this to yourself while swimming, you will square and then you see that you can't solve. So this is a very important exercise. But if you told me that x is equal to square root of u minus v and y is equal to u plus v, then I get x is equal to u minus v, y is equal to x squared, and y is equal to u plus v. If you add, this is a linear equation, you want it, so I can use, yeah, u is equal to half x squared plus y, and v is equal to half y minus x squared. So even in designing problems, you learn something. So this is what we did in my classes all the time. We were also relieved by other things other than peroxide blonde. In one class, there was some student who said, I can balance a chair on my nose. So the class stopped. I was very intrigued. So he balanced a chair on his nose. This was pre-cell phone days, so no one took a picture. So that was in the student building. I have had many such incidents in my classes, all quite remarkable. But he told me that he really hated pre-calculus, but at the end of the class, he was quite happy and he got a very good grade. So there were many such things.
We come in and ask the questions that we have on the notes or
Yes,
on the work.
anytime. Actually, what I will do, I have two telephones. One of the phones I want to dedicate to the CCP questions. And then you can just call me and ask. No, with the other number, it will work. So it is very important to understand that you have to actively participate in the learning process. And in recent times, the best class I had when that was when Nathan was, you were with Frank Demaga in 263, right? That was a very nice class.
Behind the scenes, I don't know something that you were expecting, like laugh with an oh ho ho ho.
Yes, actually, Sheila sent me the bingo board. They probably don't know what a bingo board is, as I didn't either. So
I know what's the bingo.
No.
The
A
game,
bingo
right?
board is a different thing. So you should explain to them what a bingo board is.
It's a 5x5 grid and the space on it, and when something in space gets, it happens, you fill it in, and you get a row, column, or diagonal.
Yeah, you say bingo. Yeah. They do it in church and stuff like that.
And they sent me the bingo board. At the end, Sheila sent it to me. And he said all sorts of things. He spoke again in a foreign language. Because I used to speak to Frank in French. Frank and Josiah in French. And anyway, I made Frank the detective in one of the problems in 260 that no one solved. No, I mean, sorry, Frank, not the detective, but the murderer. No, the murderer. Yes, there was a murder committed. People were giving various pieces of information, but you had to use graph theory to solve it. Anyway, so you make up the problems like this, and then you work it out. That's the best way to learn. Okay, so again, my diagnosis is that there is trouble at the level of basic algebra. It doesn't take very long to solve. Or the trouble, I mean, can be ended with not a tremendous amount of effort. At best 1 month. Okay, I think we should stop the recording.